Okay, welcome to our live stream of code review with AppMap. So this is going to be super informal. I'm just going to go through a realistic scenario. You can see on my browser here, the repo is appland inc appmap server. So that is our own repository at appland here, which is... it's app.land. It's our server-based app where you can upload and share and manage your app maps. So I'm just using that as an example because it's a nice repository that I have available to me. You don't need to know a ton about it. It's pretty standard web application architecture with mostly vanilla Rails, all the way from top to bottom, Postgres, and not too much JavaScript. The main thing we're doing with JavaScript is just this UI display, which is the same thing that you see in your code editor if you're using our code editor extension. So I'm going to cover what we find to be a really useful way to use app maps, and this is something that we've been doing for quite a long time, and find it really helpful to understand and review pull requests that are, and code changes that are making fairly substantial changes to how the app works. So this is what you would have available to you in GitHub. Basically your source diff, and assuming I don't know a whole lot about this app from the get-go, this isn't the biggest pull request ever, but it's definitely not the smallest one either. So what I really want to do is start from the beginning, figure out what kind of changes are in here, and satisfy myself that things are being done in a good way, that I'd be happy to merge into my code base. I'm not going to worry too much about, code formatting and stuff like that. That stuff is good to do too. Use a linter, use Robocop, and whatever other tools are available for your language. Review the low-level logic. Definitely do all that stuff. But what I'm looking at here with appland is going to be the higher level behaviors, the data model, the web services, and how things fit together, and does this PR fit nicely into the way that this app works. So there's a couple different ways we could go about doing this. Briefly, the bottom-up way and the top-down way. I would think of that as being starting with the data model changes and going up, or starting with the web service changes and drilling down. This is basically what I'm looking at here. Maybe I can make this all a little bigger. And feel free to slow me down or ask me to move windows or make stuff bigger or smaller or explain something again or whatever you want. Otherwise, I'll just keep going. So this is basically the same file diff view that you have in GitHub, and I've got it locally in my VS Code editor. You can do the same things with other editors like JetBrains. This is a Ruby app. You can do the same stuff I'm doing with Python and Java, but this is our app, so this is the environment that we're in. So if you've been through some of our stuff, AppMap videos and things like that, one of the things that we do is whenever you make a code change, you can generate this Swagger file, and we don't really use it that much for documentation in terms of GUI doc and reading what the web services are. What we use it for is a really authoritative way to see the changes that are happening in the web services. And this is generated completely from the code base. So of course I have this stuff all set up already in this prepared repo. If we flip over here and look at the app maps, I've generated all the app maps for this branch. Down here you can see there's 447 of them currently. If I wanted to do that, I would do AppMap equals true, bundle exec, PE is my little alias for that, rspec. And that would start generating and updating app maps. I'm not going to do that because it takes a while and that's not what people want to see happening here. But take my word for it. If you do that, you get this big list of app maps, and if you run rake appmap swagger, then it generates these two files here, which are OpenAPI _stable and OpenAPI.yaml. OpenAPI.yaml has all the doc pulled in and things like that. The stable version omits the doc and example strings because those are likely to change in ways across versions that aren't important to the API itself. They're just useful for people who want to actually look at this in the Swagger UI. But I'm going to stick with the stable file, and I can go down through it and look at the changes between what's on master and what I have locally. So some of these are just a little bit of extra info that it's picking out. It's figured out that this is an HTML route as opposed to some other kind. That's fine, not something I really need to dig into deeply. The changes start to come in more significantly down here. And if we look at the pull request, this branch is actually based on, if we look at the commits, maybe is a good place to go. Redirect the user to an uploaded app map after login, make accessible app maps downloadable, and down here, make app maps deletable by owner. So this PR is doing more than one thing here. Maybe it's better to break those up into different PRs, but whatever. We take this as we find it. So this big block here shows that. Now I should briefly explain like a little bit of this nomenclature. So scenario is like the server-side word for AppMap. So we used to say, oh, you record an app map of a scenario and then you upload that scenario. If you go to the website app.land, then you'll see that they're called app maps now, which is just more standard and matches your expectations of what that data should be called. So inside the app, in the UI, it's called AppMap. Inside the server, it's still called scenarios because that's what the database table is called. So we haven't changed that. So when a developer adds a feature to delete an app map, they're adding a delete method, HTTP method, to scenarios/ID. So this is the ID of some app map. And this, again, is the HTTP method. So that's your standard like REST style routing. It's going to take one parameter, which is the scenario ID, and that parameter is found in the path, which is this guy. And there are three different statuses that can happen: a 302 redirect, a 303 redirect, and a 404. So 404 is going to happen when you try and delete an app map that doesn't exist, or maybe you don't have permissions. We can dig into that and see what those different scenarios are. And then there's a couple of different redirects, and I don't know why those happen. We'll get into it. We'll figure it out. There's a bunch of stuff here that's all here before and not changed. getting an app map, making a head request. This is a 500, which is unexpected to me, probably worth digging into at some point. I can make a note of that. And then here's the other feature that's been added: download a scenario. So when you're in the app, when you're in the UI, and I have it open here, you can get this little button, download AppMap. So if you push it, then the scenario is downloaded. If I'm not sure if there would be a way through the UI to actually do that, because if I'm logged out, because probably this button is going to be hidden. I get a 404 on the page itself, which is fine. That's what I want to happen. But there's still going to be a server-side check to make sure that you can't download an AppMap that you don't have access to. And that's probably the 404. And we'll dig into that a little bit too. Okay, so we've got two different things to look at: delete and download. If I look in the file diff here, honestly, I'm gonna stick with AppMap as a way to navigate this. I think I'm not really even sure where I would start here, so I guess I'll go over here, and let's say we're going to filter down the download options, the download app maps. So there is one thing that I want to know, which I really want to get like from the code itself, and that is test cases, right? So I could get this over on GitHub also. I can see here that there are two new tests added, one for destroy and one for download. So that's good. That tells me that when I search my app maps for download, I'm going to be finding some tests. It's these three tests, and the names of these tests correspond to the names of the test cases here. So download when the user is anonymous and link sharing is enabled, then you can download the scenario. So we'll start there. If we flip back to this UI and explain what link sharing is. So you saw before when I logged out and tried to go see an app map, that wasn't allowed. If I turn this little public button on, then that enables anyone to come and download this, like even if they're logged out. So let me try like a incognito window, go over to this page, and I can see it. I didn't get a 404. Welcome to the app map, gives me some instructions, and the download button's here. So great. That's what this test case is also verifying. I'm anonymous, not logged in, link sharing's enabled, then I can download the scenario. So I can see some of the interesting things over here in this kind of labels area in the app map. I can see that in this case the user is public. So if I pop over here, maybe hide this and this to get a little more space, I'm going to find out that if I try and go through this route with authentication, there's two different things that might happen. I might be getting into the code with authentication, meaning with the user logged in, or I might be going in with an anonymous user, which means nobody's logged in and I'm using public access, right? So this is the trace view that corresponds to that with an anonymous user. So All right. This is going to be kind of a mouthful, but let's dig into the next thing. We looked at how the code flow looks on the dependency view. We can see that for this route, there's a web service. It goes into ActionPack, which is a Rails library. It goes into app models, which is our app code. It goes into app controllers. And if we want to know where any queries are coming from, they're coming from ActionPack, specifically from this action controller instrumentation. And queries are also being, let me close this one. Queries are also being issued from the models, which is in a model view controller architecture, like that's what you would expect to see. So we mentioned that scenario is the table that holds the app maps. There's also a table called scenario data, which stores app maps when they're just freshly uploaded and haven't been processed yet. So we can see that that's where all our queries are coming from, scenario data and scenario. If we want to know what ActionPack is doing with the database, because that's a little weird, why do we have queries that are not coming from the model? Well, it's related to transactions. That's the Rails, or it's a kind of a round hook that's beginning the transaction, or in this case, it's a save point, and then release. So that's fine. We don't mind the framework, managing that transaction stuff for us. It would be weird to see it querying directly into the database or something. That would be odd. So what I wanted to show with this is that this can give you a good picture of what the actors are in this code base. It doesn't give you a good idea of how things flow through time or sequentially. Like, I don't know really where the beginning or the end is. Things don't begin in the database, but I would guess that they start here, but this box is in the middle, it's not at the left. So this is a good place for seeing what code is participating and which code communicates with which other code. It's not that useful for stepping through and seeing how things go in sequence. That's the role of the trace view. So if I flip over, now everything here belongs to one of those boxes on the dependency map, but it's laid out exactly in order of how things happened. So the download request came in to this controller with a particular UUID of a scenario or AppMap. And the response was in JSON and with a 200 status code. That flowed through the Rails framework. And the next thing that happened was before actions. So if you're familiar with Rails and how a lot of other web frameworks happen, you can set up basically a before actions. So things that happen before your application logic. And that makes it easy to reuse them. Like you can say, hey, every action the user should log in first. Instead of putting that into every single method of your backend, you just say before action, log in, and then it'll always happen unless you disable it. So once you see enough of these app maps, like that pattern is like very familiar. So you'll see invoke before. Here's another action that's happening before, because there can be more than one. Then you'll see your actual like logic that's like specific to this particular method, and then things that happen after. And in that case, there's going to be this save point and release like wrapped around the method. So the first thing that we're doing is exactly what I described, which is setting up some, actually not exactly what I described. This is just a flag for this route that says, hey, is it ever possible for anonymous users to get anything other than like a go away and log in response for this method? And in this case, that is allowed because we just did that, and in fact that's what we're testing. We're saying, yeah, there are cases for this download action where anonymous users are allowed to do stuff. So we'll set that up ahead of time. And then there's this other interaction with the session where this is related to turbolinks. So this isn't our code, this is Rails turbolinks feature doing something that it needs to do, and I don't even know what that is, but there it is. One of the things that AppMap does is it grabs every single interaction with the session, because sessions are related to security, and so you want to know what's touching the session. You can go through all of those for any route and quickly find them, which is good. We start a transaction. Nothing has touched the database yet. Now we're in a transaction. Great. There's two things that the AppMap Cloud app is going to make you do. One is find out if the user is logged in or not. So that's check current user. And in this case, it's okay. In other words, we return true if anonymous access is allowed, which it is, and there's no logged in user, which in this case is probably what we're going to see. AppMap server also has a EULA, so a user license. So if there's a logged in user, then you'll get redirected to the EULA page. On anywhere you enter the app, it'll send you to the EULA page. You sign that, then you can continue with whatever you're doing. So that sets up the user. In this case, we know we're not logged in. If we wanted to check that for sure, we can go here to the current user method. It looks up the user in the session, which uses this user ID key. And in AppMap, in the trace view, you can see these little, this is the return value. So on the left-hand side of the box, those are the parameters that came into the function. On the right-hand box, those are the results that come out. And so when it's blank, that basically means this method returned no, or nothing, or no result. So if we look at the source code, current user, it is looking up the session user, which happens right down here, and then it's either going to return that user or it's going to return basically no, which is what it did. So in this case, nil is okay because anonymous access is allowed. So that's all been set up by this before action. And now we're going to get into the meat of the actual functionality. So every method has wrapped around it this with authentication method. So if there's a current user, then proceed. If there's no current user, then pass through this method, which indicates that the user is anonymous, and it's going to put this public label on the box, right here. So that's what makes it easy for us to, we're coming completely into this AppMap, imagine, and we just want to go figure out like where that logic having to do with the user being not logged in, public, is happening. We can click on the label, show and trace, and we're right there. Okay. Then we do some before stuff. Okay, configuration. This is, well, let's say we don't know. It's basically doing some feature flags. So these are all the different feature flags that might get turned on or off for any route. So whatever requests you come in, there's feature flags. Those need to get loaded ahead of time. It's checking the current user, which is going to the session. Again, we know there isn't one, but that's fine for this case. And then it's scenario search actions find. So that's kind of interesting. This is actually like our route specific code. This isn't just check that there's a user for every single route ever. This is more specific. So if we wanted to figure out like, hey, why is this route like looking up the user? Well, if we go back here again, requires a little bit of knowledge of Rails, right? But if you go to the controller, then up here in the before action, this is where before and after actions are configured. Find scenario. So this is really part of the controller logic, but the way Rails organizes it is things that happen before the body of the method, things that happen after. So because there's a lot of different controllers that need to find, this scenario or AppMap, that's just refactored out into its own module, included as a before action. So as we drill down, into this, eventually we find what we would have expected to see, which is a query, which is finding that scenario. So this query is pretty well known to me because, like I said, this finding an AppMap, that's a pretty fundamental part of the AppMap application. So I know this query well. I can check and maybe in the diff and see that this query hasn't been changed. I know that in this particular PR, to get back to the goal of reviewing a PR, not just learning all about AppMap, which is mostly what I've been doing so far. But it has this clause where public equals true. So the reason why this method isn't just like select ID from scenarios where some UUID is equal to something is that this is also where the permissions checking is happening. So if it's in a public map set, which is like a bunch of app maps together, permissioned as a unit, then anonymous users can see it. If link sharing is true, then you can also see it. And if I was logged in, it would also say, if I'm logged in as a user who belongs to an organization that can see this app map, then that would be valid too. So this is actually permissions checking stuff happening here. So mostly what I wanted to see from the standpoint of this pull request, if you kind of going back to what we were looking for in the first place, let me just step back up through all these back to the beginning, was that this test case is looking at anonymous access. We've seen how the user is not logged in, but that's okay. That check explicitly happens in the code. It also happens in the query, and the user ends up getting their 200 status code and getting their data. And I showed you how that works through the UI, right? Also, which is a nice check. But hey, I also want to see how it's working. Just seeing the happy path in the UI is not good enough. There's a couple other scenarios that are tested here. This one is going to be the user's anonymous. The scenario is not found, right? So here we have the user is public again, but in this case, link sharing is not turned on. So net result of this request, 404, forbidden. So I've been through a bunch of the code already, and if I wanted to, I could do that again. But it might actually be a good idea for me to just go over to the test case, download spec, and say, let's see what the test case does. The user is anonymous. The scenario is not found. The next test was link share is enabled, and here's this little block that sets that up, makes link sharing true. The scenario can be downloaded. So the only difference between this test and this test is that it doesn't have this little stanza here with link sharing being switched on. So that's good to know. That's the only change between those test cases, and I've dug into all the anonymous, not anonymous behavior like pretty extensively. I'm happy with that for now. If I look at this other scenario where the user is logged in, that's this test. The user is logged in. That's set up with this little RSpec helper. Log in the admin user, and then you can see that the checks here, scenario is downloaded, class map is matching. Those assertions are the same. So if I want to quickly flip over to the AppMap, if I want to see how this is behaving from the standpoint of user login and public access, okay, no public label here. So this route is not the flow is not following the flow of a not logged in user because the label's not there. So that's good. That makes sense. If I check the session, another thing I might want to see is now I'm updating the session. This is TurboLinks again. I don't care about that. Let's see if I can step through them all. 1, 2, key. Okay. This little eyeball here is pretty cool. You can basically go through, if you have, 4 different times that the session's being accessed, you can just step through them. The first time, setting up TurboLinks. The second time, user ID. The third time, user ID again. I don't know why. The fourth time is configuration. That's the feature flag stuff. So once we load it, we set it into the session. So this method is also helpfully labeled security authentication. I should probably explain briefly how that works. You saw this with public, right? So there are some labels that AppMap puts on the code for you because they're part of Rails or Ruby or Ruby standard libraries. This one is part of my code, so I put this little comment at label, security authentication. Whenever this method is called, AppMap is going to stick that label on the corresponding event. And I've showed you how that makes it easy to jump around and find stuff. So let's pop over to the source code. So look up the session user. If there is a user ID stored in the session, then look up that user in the database. So it's not just going to trust that, oh, if that's in the session, then that logs in the user. I want to actually make sure the user's still in the database. So that's what this query happens. We don't have a notion of like deactivated users or anything where the user might be in the database but disabled or something. If we did, that would go in here. So user find by ID, that's good enough to establish that the user is logged in. All right. Let me clean up some of this stuff. we've investigated, close, thank you. We've investigated this. We've seen that the user is logged in. It's going to go to the download flow again. That's probably going to be identical. We just see that it's not, as we've said about a million times so far, the user's logged in. So maybe we can just dig into one thing that we haven't looked at before, which is what actually happens when we respond to that. So the first thing is we're setting this content disposition header, which is like one of those magical headers. In this case, if you set attachment file name, then instead of, when you click on that link, instead of the file opening up inside your browser, which is not what we want, we don't want like a bunch of JSON in our browser. We want the we want that to be saved on disk. So content disposition attachment file name, that's the HTTP HTML magic for doing that. And the only other thing we need to do is have the scenario data, which is the raw AppMap data in JSON, which is recorded when you make AppMaps, and the export file name, which is just like a little utility that takes the display name and sort of like makes sure it isn't 2,000 characters long or whatever, because then it can fail when it's trying to save onto your computer, which would be annoying because you got this far and then that happens. It's also kind of interesting to see where does that file name, where does the kind of base name for that file name come from? The scenario or the AppMap has a file name that can be obtained by looking at the metadata stanza or section of the AppMap. If you're diversion city, diversion alert. This is the spec for what an AppMap is. App blending / AppMap. In the metadata, here's a name and lots of other stuff. So if you want to ever dig into that, go nuts. The metadata section has a name, and the export file name is going to munge that into a file name that will be useful for saving this onto your disk. What are we at for time? Maybe half an hour. Maybe good for now. The rest of what we would do here in OpenAPI stable. So we dug extensively through download, anonymous use, logged in use, 200 status, which can happen whether or not you're logged in, depending on whether you're in a public map set or the link sharing flag is set, and 404, which is what you get if you don't have permission. So notice that in no case do we redirect the user to the login page because they clicked a download link. You can't redirect, you can't send someone to the login page, I don't think. At least that's not the way it works. That might be a question I would ask, like, hey, if the user's not logged in, is it possible to send them to a login page? Or is it the case that because they clicked a link that's expecting a download, then the download like either works or doesn't work? To be honest, it doesn't really matter that much, because if you don't have permission to download, the download link isn't going to be shown in the first place. So doesn't really ever come into play in a practical way. And okay, I've got like a Discord. Maybe someone's saying something.
That was probably just me saying You got like 30, we're at like 30 minutes.
Okay, great. Well, if we're at 30 minutes, then happy to take any questions from the field, dig into anything else. But the basic resources I looked at here were the open API file. If I didn't have that, because I wasn't doing the Swagger Gen thing, then I might go through like a more traditional approach of going through the controllers and seeing what's modified. In the scenarios controller, I would see that there are 2 new actions, download and destroy. So that tells me the same thing I learned from Swagger, which is that there are 2 new routes. I can also look through, actually more useful to see that as a diff. Routes RB shows me that for scenarios now I can destroy or I can download. That's pretty good. It's not as good as the Swagger file, because from the Swagger file I was able to see all the different status codes that can happen, and make sure they're the ones that I want to see, that there's both success paths and failure paths and not like happy paths only, and also that there aren't like weird non-standard status codes like 500 internal server error. Like I wouldn't want to see that unless it was legitimate for it to be there for some reason, like a timeout or something, although even that wouldn't be a great example. So yeah, I was able to see what the routes are, what were the different things that could happen, and then get in detail through how each of those would come into play. This pull request did not have any database schema changes. If it did, then I would definitely do kind of a bottom up on that to see just what those changes were and where the different fields were being used. Try and figure out if they are duplicative with something else that I already have. If they should have constraints or foreign keys, make sure those are in there too. But that's kind of out of scope for what we're doing here. So we don't need to get into that for this session. So I think that's all we're going to cover. You want to dig in more? appland.com, or my favorite page, appland.com/docs, because from here, with Quick Start, you can basically get to all the plugins and figure out how to do anything that you want to do. If you want to see more about in sort of documentation form what I did, there's a guide here, adding AppMaps to a code issue, which I think also covers what you do when you are verifying a fix or feature. This is like pretty minimal actually, so this is more about how to grab AppMaps and put them into an issue in the first place. But if you go through this through these other guides, you'll see other information here about how to use the AppMaps to do things. And another great place to go is videos. Some of these, like how to spot and fix a problem, detect an anti-pattern, those will take you through the scenario views or the AppMap views that I showed. And if we can get you to come hang out with us a little bit in Discord, say hi, ask a question. We have some surveys and things that we're doing, and probably worth mentioning that I'm sure if you become sufficiently engaged with us, then I've got my AppMap t-shirt, the swag. I asked my kids before I go on video and stream, what do I need to do? And they said, you need to be wearing your merch. So I'm wearing my merch. And hopefully I've given you everything you need to take it from here. So thanks for watching, and I'll see you next time.